Unit 3, Activity 4, Real and Complex Solutions to Quadratic Equations. In Unit 3, we have seen that some quadratic equations have no x-intercepts and that using the quadratic formula for these types of equations results in needing to calculate the square root of a negative number. In this activity, you will learn about the square roots of negative numbers and how they are used to represent the solutions to quadratic equations that have no real x-intercepts. Although this activity only seeks to provide an introduction to these complex numbers, they are an integral part of structural engineering, fluid dynamics, electric circuit analysis, particle physics, radio communication, and other fields. Some learning outcomes, you'll be able to explain how you know a solution in real or complex numbers, analyze quadratic functions that have no x-intercepts, and solve problems for the zeros of these functions using complex numbers. Also use graphs to confirm algebraic solutions, and learn to find and express complex solutions. Okay, let's start with some skills and review problems. Solve each quadratic by using the quadratic formula, then check your solutions using your calculator's graphing utility. So just to recall, our quadratic formula, that is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so you identify first a, b, and c. For the first one, we have, remember from last activity, we have to make sure that one side is equal to 0. So let's say the right side, so we subtract 12 both sides. So that is 2x squared plus 10x minus 12 is equal to 0. And now we'll be able to identify our a, b, and c. So a is equal to 2, b is equal to 10, and c is equal to negative 12. Now let's solve for x. So negative b is 10 plus or minus square root of 10 squared minus 4 times 2 times negative 12 all over 2 times a is 2. So x is equal to negative 10 plus or minus 10 squared is 100, 4 times 2 times 12 is 96, all over 2 times 2 is 4. Negative 10 plus or minus 100 plus 96 is 196 over 4. And square root of 196 is 14 over 4. So to solve for x, let's see the first one, negative 10 minus 14 over 2. Negative 10 minus 14 is negative 24 over 2 is negative 12. The other one, negative 10 plus 14 over 2. Negative 10 plus 14 is 4, divided by 2 is equal to 2. So these are our solutions, negative 12 and positive 2. The next, number 2, you can subtract 3x and 12 both sides so that the right side is equal to 0. This is now x squared minus 3x minus 12 is equal to 0. So here a is equal to 1. Oops, I'm gonna use a space here. So a is equal to 1, b is equal to negative 3, and c is equal to negative 12. So solving for x, negative of negative 3 plus or minus square root of negative 3 squared minus 4ac all over 2a 2 times 1. Negative of negative 3 is positive 3. Negative 3 squared is 9. Negative 4 times 1 times negative 2 is positive 48 over 2. 9 plus 48 is 57 over 2. So if we don't have the square root of 57, so we could just write it as 3 minus square root of 57 over 2 and 3 plus square root of 57 over 2. And if you use a calculator, this is approximately equal to negative 2.275, and this one is approximately equal to 5.275. And next I'll show you using a graphing calculator decimals. And here's using decimals. The first one, 2x squared plus 10x minus 12, and you can see the points on the x-axis, the x-intercepts. We have the x values negative 6 and positive 1. And for the second, x squared minus 3x minus 12, if you click on the points on the x-axis or the x-intercepts, and the x values are negative 2.275 and 5.275. And these are our answers, negative 6, 1, and for the second problem, 2.275 and 5.275. This negative. Okay, now let's proceed to our class discussion. Now let's start with solving the equation x squared plus 4x plus 5 is equal to 0 by using quadratic formula. So again, our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a, and with a given equation identify our a, b, and c. A is equal to 1, b is equal to 4, and c is equal to 5. Now let's solve for x. Let's substitute the values of a, b, and c. So negative b, negative 4 plus or minus 4 squared minus 4 times 1 times c is 5 over 2a 2 times 1. So this is negative 4. 4 squared is 16. 4 times 1 times 5 is 20 all over 2 times 1 is 2. So that is negative 4 plus or minus 16 minus 20 is negative 4 over 2. And we don't have the square root of a negative 4, so let's stop here. So our answer is negative 4 plus or minus square root of negative 4 over 2. Then number 2, this time use technology to craft a function f of x equal to x squared plus 4x plus 5, and the question, what are the x-intercepts? Okay, let's use decimals. So let's type the given f of x equal to x squared plus 4x plus 5. And as you can see, this is a parabola and there are no x-intercepts. There are no points on the x-axis. So you can say here for number 2, no x-intercepts. And here we can say no solutions. And to answer number 3, how do your answers to questions 1 and 2 above match each other? And again, no solutions because there are no points on the x-axis, no x-intercepts. Okay, number 4. The quadratic equation x squared plus 4x plus 5 equals 0 appears to have no solutions since we cannot compute the square root of a negative number. And that's what happened for number 2. Traditionally, we say there is no real solution. The square root of a negative number is usually now called an imaginary or complex number. The phrase imaginary number was first used in the 1600s as a derogatory term to demean those who dared to think that such numbers existed. Until the 20th century, most scientists and mathematicians thought these numbers were useless, though now they are integral to the development and understanding of many scientific fields and mathematical formulas. To define the complex numbers, we start with the following. The imaginary unit is the square root of a negative 1, so we use square root of negative 1 is equal to I. So take note of this. Square root of negative 1 is equal to I. So from number 2, remember we solve this part here and we stop here. Negative 4 plus or minus square root of negative 4 over 2. And then we can say that negative 4 is 4 times negative 1. And we can separate that as square root of 4 times square root of negative 1. And we know that the square root of 4 is 2. And square root of negative 1 by the definition is equal to I. So that's why we have negative 4 plus or minus 2i over 2. Then we can separate this. Each term divided by 2. Negative 4 divided by 2 is negative 2. And 2i divided by 2 is I. So this is our final answer, which are the solutions for x, negative 2 plus I and negative 2 minus I, and we call these r as complex numbers. And as you can see, these numbers are in the form of a plus bi, plus or minus bi, where I is a real number and bi is an imaginary number. Okay. Now, let's go back to our Desmos to find the vertex of the given function f of x equal to x squared plus 4x plus 5. And the vertex is negative 2, 1. So that's the minimum, negative 2, 1. Let's go back to our notes. So the vertex is negative 2, 1. In activity 3, we created a formula x equal to negative b over 2a that finds the x-coordinate of the vertex of a quadratic equation. The formula is based on the fact that the x-coordinate of the vertex of a quadratic equation must be the average of the two x-intercepts, and that's precisely in the middle. Now we want to find the average of the two complex x-intercepts we found for f of x equal to x squared plus 4x plus 5. And just to recall, we had the two solutions for x, negative 2 plus I, and the other one, negative 2 minus I. Now let's find the average of this. That is negative 2 plus I plus negative 2 minus I divided by 2. That is negative 2 plus I plus minus 2 minus I over 2. I minus I is 0. This is negative 2 minus 2 is negative 4 over 2 is equal to negative 2. That's why we have it as the vertex x is equal to negative 2. Try another problem. Number 5. Consider the equation x squared minus 3x plus 10 is equal to 0. Letter A. Confirm that the equation has no real solutions by graphing the function using Desmos, and answer this question: what aspects of the graph tells you that there is no real solution? Okay, let's use Desmos. Type the function f of x equal to x squared minus 3x plus 10, and as you can see, there are no points on the x-axis, there are no x-intercepts. That's why this function has no solutions. Now let's use the quadratic formula to find the complex solutions to the equation and round decimals to 4 places of accuracy when needed. So given this equation, identify A, B, and C. A is 1, B is -3, and C is equal to 10. So again, the quadratic formula, -b plus or minus square root of b squared minus 4ac all over 2a. So let's substitute a, b, and c. Negative of -3 plus or minus -3 squared minus 4ac all over 2a times 1. So this is negative times -3 is +3. -3 squared is 9. -4 minus 10. 4 times 1 times 10 is -40. Plus or minus 3 plus or minus 9 minus square root of 9 minus 40 all over 2 times 1 is 2. And that is 9 minus 40 is -31 over 2. So the answers, plus or minus, you can write square root of 31 times square root of -1 over 2. And that is, we know that square root of -1 is I. Or we can rewrite this as 3 plus or minus I square root of 31 over 2. So the two answers, complex solutions, minus I square root of 31 over 2, and x is 3 plus I square root of 31 over 2. Okay, then number 6. This time solve the equation -3x plus 12x is equal to 24. We can subtract 24 both sides, and that is -3x squared plus 12x minus 24 is equal to 0. And here, before we use the quadratic formula, since -3, 12, and -24 are all divisible by -3, we can divide both sides by -3. And that gives you -3 divided by 3 is x squared, 12 divided by -3 is -4x, -24 divided by -3 is +8, 0 divided by -3 is 0. So that we can have here a is equal to 1, b is equal to -4, and c is equal to 8. Now let's use the quadratic formula. Negative b, so negative of -4 plus or minus square root of b squared, so -4 squared minus 4ac all over 2a, 2 times 1. Negative times -4 is +4. -4 squared is 16. 4 times 8 is -32 over 2 times 1 is 2. 4 plus or minus 16 minus 32 is -16 over 2. 4 plus or minus square root of 16 times square root of -1 over 2. So let's continue that here. 4 plus or minus. Square root of 16 is 4. And square root of negative 1, remember that is equal to I all over 2. So we can have this is 4 over 2 plus or minus 4 over 2I, and that is 4 over 2 is 2, 4 over 2 is 2I. So that this complex solutions are x is equal to 2 minus 2I and x is equal to 2 plus 2I. Okay, so that's it for Unit 3 Activity 4. Let me know if you have any questions. Thank you.